Advances in mathematics in ancient Egypt. Mathematics in ancient Egypt represents one of the earliest and most fascinating chapters in the history of human thought. The Egyptians developed a sophisticated and practical approach to mathematics that was integral to their civilization. Their achievements in this field laid the groundwork for many mathematical concepts and practices that are still in use today. This comprehensive exploration delves into the origins, development, and impact of mathematics in ancient Egypt, spanning from the early dynastic periods to the later periods of the pharaohs. The origins of Egyptian mathematics. Early dynastic period, before 3000 before Common Era. The origins of Egyptian mathematics can be traced back to the early dynastic period, before 3000 before Common Era. During this time, the Egyptians began to develop a numerical system and basic arithmetic operations to manage agricultural activities, construction projects, and trade. The need to measure land, calculate areas for taxation, and keep accurate records of resources necessitated the development of mathematical skills. The earliest evidence of Egyptian mathematics is found in the form of inscriptions on pottery shards, bones, and other artifacts. These inscriptions show the use of numbers and simple arithmetic operations, indicating that the Egyptians had already started to develop a rudimentary mathematical system. Old Kingdom, approximately 2686 to 2181 before Common Era. During the Old Kingdom, approximately 2686 to 2181 before Common Era, the Egyptians made significant strides in mathematics, particularly in the areas of geometry and measurement. The construction of the pyramids during this period required precise mathematical calculations to ensure the structure's stability and alignment. The use of mathematics in construction is evident in the dimensions and proportions of the pyramids, which demonstrate an understanding of geometric principles. The Egyptians used a system of measurement based on the cubit, which was divided into smaller units such as palms and fingers. This system allowed for precise measurements, essential for constructing large and complex structures. Egyptian numerical system. Hieroglyphic numerals. The Egyptians developed a unique numerical system based on hieroglyphs, which were used to represent numbers. This system was decimal, meaning it was based on the number 10, and used different symbols for each power of 10. For example, a single stroke represented the number 1, a heel bone symbol represented the number 10, a coil of rope represented the number 100, a lotus flower represented the number 1000, a finger represented the number 10,000, a frog represented the number 100,000, a man with arms raised represented the number 1,000,000. This system allowed the Egyptians to represent large numbers by combining these symbols. For example, the number 2345 would be represented by 2 lotus flowers, 3 coils of rope, 4 heel bones, and 5 strokes. Hieratic numerals. In addition to the hieroglyphic system, the Egyptians developed a more simplified numerical system known as hieratic numerals. This system was used primarily for administrative and accounting purposes, as it was easier and quicker to write than hieroglyphs. The hieratic numerals were based on a similar decimal system but used different symbols and a more cursive writing style. Arithmetic operations. Addition and subtraction. The Egyptians had a straightforward method for performing addition and subtraction using their numerical system. They would combine or separate symbols representing different powers of 10 to achieve the desired result. For example, to add 2,345 and 1,678, they would combine the symbols for each power of 10, 2,345, 1,678. By combining these symbols, they would arrive at the sum of 4,023. Multiplication and division. Multiplication and division in ancient Egypt were performed using a method known as doubling and halving. This method involved doubling or halving numbers and then adding or subtracting the results to achieve the desired product or quotient. For example, to multiply 12 by 15, they would use the following steps. 1. Write the numbers 1 and 12. 2. Double the numbers 2 and 24, 4 and 48, 8 and 96. 3. Identify the powers of 2 that sum to 15, 1, 2, 4, 8. 4. Add the corresponding products. 12 plus 24 plus 48 plus 96 is equal to 180. This method allowed the Egyptians to perform complex calculations using simple arithmetic operations. Geometry and measurement. Land measurement. One of the primary applications of mathematics in ancient Egypt was land measurement. The Egyptians developed advanced techniques for measuring and dividing land, which were essential for agricultural activities and taxation. They used a unit of measurement called the sedet, which was equivalent to approximately 2,756 square meters. The Egyptians employed surveyors known as harpedinapti, who used ropes marked with regular intervals to measure land. These ropes, known as knotted cords, were used to create right angles and measure distances accurately. The harpedinapti played a crucial role in maintaining accurate records of land ownership and ensuring that agricultural land was divided and taxed fairly. Construction and architecture. Geometry was also essential for construction and architecture in ancient Egypt. The Egyptians used geometric principles to design and build structures such as temples, pyramids, and tombs. The construction of the Great Pyramid of Giza, for example, required precise calculations to ensure the structure's alignment and stability. The Egyptians used a system of proportions and ratios to design their buildings. They were familiar with the concept of the golden ratio, which they used to achieve aesthetically pleasing proportions in their structures. The precise alignment of the pyramids with the cardinal points of the compass also demonstrates their advanced understanding of geometry and astronomy. Practical geometry. Practical geometry was used extensively in various aspects of daily life, including construction, agriculture, and trade. The Egyptians developed techniques for measuring areas, volumes, and angles, which were essential for building structures, dividing land, and conducting trade. For example, they used geometric principles to calculate the area of fields and the volume of storage containers. They also developed methods for creating right angles and parallel lines, which were essential for constructing buildings and irrigation systems. Mathematical texts and documents. Rhind mathematical papyrus, approximately 1650 before Common Era. One of the most important sources of information about ancient Egyptian mathematics is the Rhind mathematical papyrus, dating to approximately 1650 before Common Era. This document, also known as the Ames Papyrus after the scribe who copied it, contains a collection of mathematical problems and solutions. The Rhind mathematical papyrus provides valuable insights into the mathematical techniques and practices of the ancient Egyptians. It includes problems related to arithmetic, geometry, and fractions, as well as practical applications such as calculating the area of fields and the volume of storage containers. Moscow mathematical papyrus, approximately 1850 before Common Era. Another significant mathematical text is the Moscow mathematical papyrus, dating to approximately 1850 before Common Era. This document contains a collection of mathematical problems and solutions, similar to the Rhind papyrus. The Moscow mathematical papyrus includes problems related to geometry, such as calculating the volume of a truncated pyramid and the area of a circle. The Moscow mathematical papyrus provides further evidence of the advanced mathematical knowledge and skills of the ancient Egyptians. It demonstrates their ability to solve complex geometric problems and apply mathematical principles to practical tasks. Berlin papyrus, approximately 1800 before Common Era. The Berlin papyrus, dating to approximately 1800 before Common Era, is another important mathematical document from ancient Egypt. This papyrus contains a collection of mathematical problems and solutions, including problems related to fractions, geometry, and algebra. The Berlin papyrus provides valuable insights into the mathematical practices and techniques of the ancient Egyptians. It demonstrates their ability to solve complex mathematical problems and apply their knowledge to practical tasks. Fractions and arithmetic. Unit fractions. The Egyptians used a unique system of fractions based on unit fractions, which are fractions with a numerator of 1. For example, the fraction 2/3 would be represented as 1/2 plus 1/6. This system allowed the Egyptians to perform complex arithmetic operations using simple fractions. The use of unit fractions is evident in various mathematical texts, such as the Rhind mathematical papyrus and the Moscow mathematical papyrus. These documents contain numerous problems and solutions involving fractions, demonstrating the Egyptians' advanced understanding of arithmetic. Arithmetic operations with fractions. The Egyptians developed techniques for performing arithmetic operations with fractions, such as addition, subtraction, multiplication, and division. They used methods similar to those used for whole numbers, such as doubling and halving, to solve problems involving fractions. For example, to add 1/2 and 1/3, the Egyptians would find a common denominator, 6, and then combine the fractions. 1/2 equals 3/6. 1/3 equals 2/6. 1/2 plus 1/3 equals 3/6 plus 2/6 equals 5/6. This method allowed the Egyptians to perform complex arithmetic operations with fractions using simple techniques. Algebra and problem solving. Algebraic equations. The ancient Egyptians developed techniques for solving algebraic equations, particularly linear equations. These techniques are evident in various mathematical texts, such as the Rhine Mathematical Papyrus and the Berlin Papyrus. The Egyptians used methods similar to those used in modern algebra, such as balancing equations and isolating variables, to solve problems. For example, one problem from the Rhine Mathematical Papyrus involves solving the equation x plus 1/2 x equals 10. The scribe uses a method similar to modern algebra to isolate the variable and solve the equation. X plus 1/2 x equals 10. 1 plus 1/2 x equals 10. 3/2 x equals 10. X is equal to 10 times 2/3. X equals 6 and 2/3. This method demonstrates the Egyptians' advanced understanding of algebraic principles and their ability to solve complex mathematical problems. Practical applications. The Egyptians applied their knowledge of algebra and problem solving to various practical tasks, such as calculating the area of fields, the volume of storage containers, and the distribution of resources. They used mathematical techniques to solve real-world problems and manage various aspects of daily life. For example, they used algebraic equations to calculate the amount of grain needed to fill a storage silo or the number of workers required to complete a construction project. These practical applications demonstrate the Egyptians' ability to apply mathematical principles to solve practical problems. Impact and legacy. Influence on Greek mathematics. The mathematical achievements of the ancient Egyptians had a significant impact on the development of Greek mathematics. The Greeks, particularly scholars such as Thales, Pythagoras, and Euclid, were influenced by the mathematical knowledge and techniques of the Egyptians. They adopted and built upon Egyptian mathematical principles, incorporating them into their own mathematical theories and practices. The Greek mathematicians made significant contributions to the field of mathematics, but their work was heavily influenced by the foundations laid by the Egyptians. For example, Euclid's Elements, one of the most important mathematical texts in history, was based on principles and techniques developed by the Egyptians. Influence on modern mathematics. The legacy of Egyptian mathematics can be seen in various aspects of modern mathematics. Many of the mathematical concepts and techniques developed by the Egyptians, such as arithmetic operations, fractions, and geometry, are still in use today. The Egyptians' practical approach to mathematics, which emphasized solving real-world problems, continues to influence modern mathematical practices. For example, the use of unit fractions and the method of doubling and halving are still used in various mathematical calculations. The Egyptians' contributions to the field of geometry, particularly their understanding of proportions and ratios, have had a lasting impact on modern mathematics. Preservation and study of Egyptian mathematics. The preservation and study of ancient Egyptian mathematical texts have provided valuable insights into the mathematical knowledge and practices of the ancient Egyptians. Scholars and researchers have studied these texts to understand the Egyptians' mathematical achievements and their contributions to the field of mathematics. The study of Egyptian mathematics has also provided valuable insights into the development of mathematical thought and the history of human civilization. By understanding the mathematical achievements of the ancient Egyptians, scholars can gain a deeper appreciation of the role of mathematics in shaping human history and culture. Conclusion. The advances in mathematics in ancient Egypt represent one of the earliest and most significant chapters in the history of human thought. The Egyptians developed a sophisticated and practical approach to mathematics that was integral to their civilization. Their achievements in arithmetic, geometry, fractions, and algebra laid the groundwork for many mathematical concepts and practices that are still in use today. The impact and legacy of Egyptian mathematics can be seen in the development of Greek mathematics and its influence on modern mathematical practices. The preservation and study of ancient Egyptian mathematical texts have provided valuable insights into the mathematical knowledge and practices of the ancient Egyptians, contributing to our understanding of the history of mathematics and human civilization. Through their advanced mathematical knowledge and practical applications, the ancient Egyptians demonstrated their ability to solve complex problems and manage various aspects of daily life. Their contributions to the field of mathematics continue to be celebrated and studied, highlighting the enduring legacy of Egyptian mathematics in shaping the history of human thought and civilization.